So in the previous sections, we did everything arithmetic, everything geometric. We even hinted a little bit at sum when we were looking at those word problems. Now we're going to talk about, okay, we don't have a word problem, oops. And if I'm finding the sum, it's kind of annoying if I have to add. Like if you have to add the first 100 numbers, 1 plus 2 plus 3 plus 4, dot, 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 all the way to 100. You don't really want to do that. And you could actually find a pattern, though. You could be like, oh, 1 plus 99 is 100. 2 plus 98 is 100. 3 plus 97 is 100. And then figure out that there's 50 of those, get the answer, and go from there. But what if it's a pattern like 3 plus 7 plus 11 plus 15 plus dot, 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 up to a crazy number? And you had to add all of those, which is realistic. That's what you're going to be doing, taking the total. Okay? It's kind of annoying to do it this way. So if you look here, there's two types. There's the arithmetic. So if we're dealing with arithmetic, remember it's an adding and subtracting pattern. That means it's a sub, that means we're using the formula, and I'm going to put that in here. A sub n equals a1 plus n minus 1 times d when we're dealing with arithmetic. When we're dealing with the sum, you're going to use this formula. And then there's geometric. Geometric is a multiply, not a divide pattern. What we do is we multiply by the reciprocal. And these are the two sum formulas, but let me write down the geometric formula to remind you. These are the formulas, or these are the formulas to get the rules for an arithmetic, the rule for a geometric. But these here, and let me highlight them, are the formulas to find the sum. Okay? And don't worry, you'll know when. There's two different types. There's a finite, which means it ends. I want the sum of the first 10 numbers. That ends. I can actually do that. And then this is infinite. This means I want the sum of all the numbers forever and ever and more. What would that sum be? Now, there are limits, because if your number just keeps getting bigger and bigger, so if you had 3 plus 6, and then this is like times 2 times 2 times 2 plus dot, 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 how are you supposed to find the total of that? Because it just keeps getting bigger and bigger, there actually wouldn't be a sum. You couldn't figure it out. And you're going to learn it's because the ratio is greater than 1. When the ratio is greater than 1, then there is no sum in a geometric series. Okay? But if it's less than 1, so let's say that's 1/3. So let's say it's times 1/3. So it'll be plus 1, plus 1/3, plus 1/9. Okay? This is exponential decay. It's gradually getting so small that those little minuscule numbers can add up to a number, and you could find the value, and that means it converges. You can do it. And we'll talk about that, okay? So the first thing we do is we look at the pattern. Let's look at the pattern, zoom it in, and we have to decide, is it arithmetic or geometric? So I look at the pattern and I go, oh, it's plus 3. If it's plus 3, boom, it's arithmetic. So I'm going to use this formula. S sub n equals n a1 plus a to the n over 2. The reason I'm writing it down is because that's how I remember it. I only see this once a year, so if I need to relearn it, the way I'm going to do that is to write it down. So let's see here. They want the sum of the first 15 numbers. So I'm going to put 15 right in there. So I'm going to go 15 times. And they want a sub 1. So I'm going to put my a sub 1 right there. And I'm going to talk about that a sub n in a second, okay? The a sub n represents the last number in the series. What is that 15th number? We don't know what the 15th number is. We know what the first number, the second number, the third, and the fourth. But how are we going to get the 15th? Oh, we got to go back to this formula. So I can either do an equals a1 plus n minus 1 times d. Plug in 4, n minus 1 times 3, 3n minus 3 plus 4, 3n plus 1. And that's my formula for my a sub n. Or I could go, remember the patterns here. If this is plus 3, this is minus 3, that's my 0 term. Then I have to take that 15 and I plug it in. 3 times 15 is 45, plus 1 is 46. So the 15th number in this sequence, and it's a sequence because it doesn't say plus, is 46. And now I simplify. 46 plus 4 is 50, And then 50 times 15 is 750, divided by 2 is 375. So the sum of the first 15 numbers is 375. Who would have thought that added up so quickly? And if you don't believe me, you can list them. You can go 4, 7, 10, 13, 16, 19, 22, 25, ... all the way to 46, and then add all those numbers and see how quickly they add up. And this reminds me of a credit card bill. $20 here, $20 there. It doesn't seem like a lot, and then boom, out of nowhere, that's your credit card bill, okay? Which is probably going to be more. All right, let's look at the next one. Let's look at the pattern here. What is the pattern? Oh, times 2. Well, if it's times 2, that means automatically it is geometric. They want the sum of the first 10 numbers, so they want this formula. It ends. So the S sub n equals A1, 1 minus r to the n over 1 minus r. Okay, so I'll use this formula. So I'm going to say the sum of the first 10 numbers is A sub 1, which now we're doing in green, so I will do that in green, 4. 1 minus parenthesis. Okay? And then I do the ratio. Oh, what's the ratio? Okay, 2. But then I have to go to the n. Well, what's my n? 10. Now, this is kind of annoying for me to put in the calculator, so I'm going to simplify it a little bit. I cannot cross those off because they're being subtracted. So 1 minus 2 is negative 1. 4 divided by negative 1 is negative 4. So in my calculator, I'm just going to go negative 4 times 1 minus 2 to the 10th power. And I get 4092. So the sum of the first 10 numbers is 4092. Okay. And some of you go, wow, that went up a lot quicker. It does. It's exponential. This is linear. It's constant. This is exponential. And we know the difference between the two. All right, let's try the next one. What am I going to do here? Minus 5, minus 5. It's also a sequence. Sorry, you can't see that. So boom, it's arithmetic. What's the formula? S sub n equals n a1 plus an over 2. Take the 23, plug it in. Take your a sub 1, 21. Now remember what I want. I want to know what is that 23rd number. I don't know it. I know the first number, the second, the third, and the fourth. So I've got to use my formula to get the answer. Or I can do it like, so now I'm going to find the 23rd term. So I'm going to take, if this is minus 5, this is plus 5, that's 26. So an equals negative 5n plus 26. Put 23 in there. I don't feel like multiplying right now. Negative 89. So that's minus 89. And now I'm going to subtract, so negative 70. Nope, I'm not feeling smart right now. 89 minus 21, 68. Wow, that was sad. Divided by 2 is 34. Hopefully I did that right. 782. The sum of the first 23 numbers is 782. All right, let's go to the next one. This is a series. It's just the difference between the addition and the sum, but it's still finding the sum. How do you know? Because it says plus ... Okay? So that means they want to know the sum of every number forever infinity. So I first have to figure out, is it arithmetic or geometric? Well, it's dividing by 2, but that's really multiplying by 1/2, so it is geometric. If it's ... that means it's going forever. It's infinite. It's this one. So the sum of the infinite numbers is a sub 1 over 1 minus half. Okay? Now, how do we know if we can do it or we can't? Do you notice how the numbers are getting smaller and smaller? So this would be 2, 1, 1/2, 1/4, 1/8. If you add 1/2, 1/4, 1/8, it kind of almost approaches 1. That's kind of what the decay is, but then it never quite gets there. So it's a possible sum to get. if I'm going to not use my calculator, 1 minus a half is a half. How many halves are in 32? 64. So the sum of all those numbers would end up being 64, because this is 48, 56, 60, 62, 63, and all those fractions will probably total 1, which makes 64. Okay, let's do the next one. All right, times 2 times 3 times 3. That means it's geometric, but they want the sum of the first 8 numbers. So I have to use the more complex formula. So the sum of the first 8 numbers, I was mixing that up from infinity, is a sub 1, 1 minus the ratio to the 8th power over 1 minus the ratio. 1 minus 3 is -2, -7. Use my calculator. And hopefully you're doing this yourself because you need to practice. This needs to be, which formula do I use? How do I plug it in? So the sum of the first 8 numbers is 45920, because my numbers are getting bigger and bigger. They are tripling. That means that's going to triple. We're over 1,000. And then we're tripling again. That's at 3,000. We're tripling again. That's at 9,000. Just triple, triple, triple. So this one is also times 3. It's the same thing. But it's a series that is saying that it goes forever. But wait a minute. We just said the numbers are getting bigger and bigger. So we can't find the total because it's going to keep getting bigger and bigger. Because the ratio is greater than 1, there is no sum. Okay? And the ratio is 3. So this would be diverge. There is no sum. This would be converge, because you can do it or don't do it. Know the difference when you have something that's multiple choice. I'm going to say converge, diverge, finite, infinite, arithmetic, geometric, sequence, series. Know all that vocabulary. Okay? They want the sum of the first 25 numbers. Now, some of you get a little confused by that, but I want you to look at it as if it's a comma. So it's -1, comma 2, comma -4, comma 8. And that means that it's being multiplied by -2. So that means it's geometric. They want the sum of the first 25. It is finite. I use this fancy formula. A sub 1 minus the ratio, and put that in parentheses because based on PEMDAS, what is it? The sum of the first 25. You have to do the exponent first, then subtract. Over 1 minus -2. So that would be 3. So give me a second to plug this into the calculator. So 1 minus -2 to the 25th. Oops, what did I do? Okay, give me a second to figure it out. I got a little carried away with my parentheses. So I did the numerator divided by 3. In Desmos, you would just do it all at once, but this isn't that fancy of a calculator. So I don't want to keep logging in. So this works, the sum of the first 25 numbers. And some of you go, how is it negative when some of them are positive? Well, if you think about it, this -4, and then you have the 2 minus 1 would cancel that out, and that would be negative. The -16 plus 8, -8, -12, 10, -10, -11. So now we're already at -11. Now let's look here. The sum of the first 9 numbers. Now this one isn't as obvious of a ratio. So what could I do? I could go 1,500 divided by 2,500, figure out the ratio, which I think is 3/5. So that means I multiply by 3/5. And what if you go, you know what, Miss Rifkin, I don't believe you. I could go 2,500 times 3/5, and I better get the next number. And I get 1,500. All right, let's go times 3/5 again. And I should get the next number. There, it's 900. So I know that I'm good to go. This is the sum of the first 9 numbers. Oh, this is about to end, so I'm going to stop it and then go to the next video.